Hi friends, so today we will start the discussion with solutions to first order differential equations. So a recap lang from the very first topic, first order differential equations So these are DEs that has a degree or rather order of 1 So meaning ang kanyang highest derivative is only the first derivative. So these DEs are in the form of P0 of x and y or x comma y, so meaning it is a function of x and y, dy over dx plus p1 of x and y is equal to 0. So basically you just need to pay attention on the derivative. So basta first derivative lang yung highest niya, so wala tayong problema doon. That is a first order differential equation. Okay, so we have actually quite many methods of solving different first order differential equations. So we have variable separable, homogeneous coefficients, exact equations, integrating factors, by inspection, so on and so forth. So we will discuss that in the course of the in the run of this course. So let's first discuss the very the easiest among all the solutions, which is variable separable. So how do we know if the FODE, yung first order differential equation natin, if the FODE falls under variable separable? So FODEs in the form of a of x dx plus b of y dy is equal to 0. These are variable separables, meaning we can segregate x from the y's, as well as with the dx from the dy. So kapag ganun yung case natin at mapapagsama natin si x at saka yung dx, lahat ng may x at saka yung dx at saka lahat ng y with the dy, automatic variable separable yung ating differential equation. And actually, we've been doing variable separable since the last topic, since the last discussion, yung sa solutions to DE, So kaya medyo madali na lang to, We're just going to integrate once we segregate, segregate then integrate. Okay, so let's try this problem, So we have x dy minus 2y dx is equal to 0. So hindi lahat ng given natin is already in this form, Hindi lahat is already in this form. Katulad ng problem na to, So magkabaliktad si y at saka si x. And that is not a problem, Bakit? We can still rearrange the equation algebraically. Then we will arrive with this form, Yung a of x dx plus b of y dy is equal to 0. So paano 'yon, For example, ito nga. So lipat ko yung 2y dx sa kabila. So we have x dy is equal to 2y dx. So dapat lahat ng y is kasama ni dy, lahat ng x is kasama ni dx, So I will multiply. Ano yung kailangan ko i-multiply? 1 over x 1 over xy. Para sa ganun, makancel ko yung x dito sa dy, Makancel ko yung x dito sa dy, makancel ko yung y sa dx. So we'll have dy, we'll have dy over y. Bakit over y na lang? Kasi nga cancel yung x. So x divided by x is equal to 1 is equal to 2 dx over x. So nasa form na tayo nung variable separable. So once we arrive with the form, we can directly get the Get the antiderivative, So the antiderivative of dy over y, so that is ln of y is equal to 2. The antiderivative of dx over x is ln x. Of course, let's not forget the arbitrary constant. Okay, so naka-ln yung variables natin, particularly the y. So we do not want that because we only need the y alone, So what are we going to do? Kapag nakakita kayo na ganito na mayroong ln, you can make this an exponent to the Euler's constant. Bakit? Kasi ang Euler's constant, kapag ang kanyang exponent is natural logarithm, makakancel yung dalawa, maiiwan na lang yung internal function ng yung internal function ng natural logarithm. So, ganun din dito sa kabila, of course, So, you need to take in consideration na kapag meron kang operation, either plus or minus, and if we have this form, no, yung e raised to a function added to another function, no, let's say, no, we need to take account this operation nga. So, remember, no, sa laws of algebraic exponents natin, if we have x raised to a plus b, diba this is equivalent to x raised to a times x raised to b. So, ganun yung gagawin natin dito. So, we will have y is equal to e raised to 2 ln x times e raised to c. Since c is an arbitrary constant and e is a constant, no, so this will just be absorbed, no. E raised to c will just be equal to simply c. So tatandaan nyo yun, no. Tapos ito naman, e raised to 2 ln x, we need to make 2 an exponent to the internal function of x. Kasi hindi natin pwede i-operate yung makaka-cancel yung e and yung ln nang meron tayong coefficient ng ln greater than or not equal to 1. No? So, this needs to be changed into an exponent. So, kapag na-change na, so we will have y is equal to e raised to ln of x squared, okay, multiplied to c. Then that's the time that we can cancel this one. So we will have y, so the function, no, the solution to the differential equation is y is equal to c multiplied to x squared. Kasi c is a constant. So pag constant, nauuna siya sa variable. So this is our answer, no? So basically, okay? So yun. Next, no, so we have here our second example. 2xy prime is equal to y squared. So, alam naman natin na ang y prime is equal to dy over dx. So, let's change that to dy over dx. So, we have 2xy dy over dx is equal to y squared. So, again, we need to isolate the y's from the x's. So, magmumultiply ako since dx is nasa denominator, dapat ang i-multiply ko nasa numerator yung dx. Then yung x, kailangan ko siyang may hiwalay, no? Kasi puro y na dito sa left side eh. So, I'll also include x. Then dito sa right side, si y dapat maalis ko rin. So, I'll include y squared. So, we'll have, makakancel yung x, yung dx, at saka yung y squared. So, we will have 2y dy over y squared, no? Yun yung dinivide natin, is equal to dx over x. Okay? Then we can get the anti-derivative. No, so this one, pwede nyo i-cancel yung y tas yung y squared, then lalabas ito. However, medyo mahahaba ng konti yung solution kasi lalabas pa nga si 2 tapos magiging ln kasi yung sagot nito, no. So kapag 2 times ln, yun still need to transform it. Pwede naman nang gawin na lang natin tong y squared as u. Diba? And if that is u, du is equal to 2y dy. So, yun yung numerator natin, du over u. So, we'll have the answer, straight to the answer, no, of ln y squared is equal to ln x plus c. Okay, yung mga ganon, no, yung mga ganong pwede nyo naman ng i-shortcut, you can do so kasi as long as it abides the rule, no, wag lang yung biglang shortcut tas di naman kulang naman pala, no, or mali naman pala. So we can make this an exponent of e para ma-cancel yung ln again. So cancel to, so we'll have y squared is equal to e ln x times e raised to c, no. So automatic pagka ganun, no, gawin nyo na agad siyang times, no? So, para at least alam niya na agad. So, e raised to ln cancel. E raised to c is equal to c. So, we have y squared is equal to c x. No? So, this is our solution. No? So, you can get the square root pero unnecessary naman na kasi general solution naman to. So, we have y squared is equal to c x. No? So, that is our answer. Okay, next example. So, we have here sin x sin y dx plus cosine x cosine y dy is equal to 0. So, again, no, let's manipulate the function. So, we have sin x sin y dx is equal to negative cosine x cosine y dy. So, nakahiwalay na yung dx and dy natin. So, let's just ensure na lahat ng kasama ng dx is x and lahat ng kasama ng dy is y, no? So, we can multiply. Alisin na natin yung mga hindi naman kasama, no? So, in this case, sin y. So, that is 1 over sin y. So, bakit siya 1 over, no? Kasi remember, nasa numerator yung sin y natin. And para makancel siya, dapat ilalagay natin na sin y is nasa denominator din. Or else, magsa-sin squared y. Yan, no? Kapag dinistribute na natin. Tapos dito naman sa kabila, dy. So, x, cosine x yung hindi natin kailangan. Ayan. So, cancel yung sin y at saka yung cosine x. So, we will have sin x over cosine x dx is equal to negative cosine y over sin y dy. Okay? Then, we can actually integrate this one, but it is easier if we use trigonometric identities, no? So, we have here sin x over cosine x is equal to tangent x, di ba? As per our trigonometric identity, so that is tangent x dx is equal to cosine y over sin y is cotangent naman, no? So, we have negative cotangent y dy. Okay, then, ayan na, mas madali na natin makuha yung antiderivative. So, we have here, the antiderivative of tangent x is ln secant x, no? Or, meron pa actually isa, that is negative ln of cosine x. However, kapag tinranslate kasi natin to yung negative ln cosine x into positive ln, so yung negative 1 dun sa unahan ng ln magiging exponent ng cosine. So, magiging from cosine, magiging 1 over cosine, and 1 over cosine is equivalent to secant x. Okay, kaya ito na lang yung gagamitin natin. Then, this is equal to negative natural logarithm of sin y. So, sir, ang integral ba or ang antiderivative ba ng cotangent y is negative ln sin y? No, it is actually only ln of sin y. However, saan nanggaling yung negative? Of course, to, yung nasa harap, no? Yung negative 1 na coefficient ng cotangent y. Of course, plus c. Huwag natin kakalimutan. Okay, so we have here the ln of secant x is equal to ln. Gawin natin positive, no? So, sin y raised to negative 1 is equal to 1 over sin y, which is equivalent to cosecant. No? So, we have cosecant of y plus c. So, we need to eliminate ln. So, let's make this an exponent of e again, no? So, maganon tayo, no? Depende, of course, depende sa problem. Pero kapag puro ln na yung lumalabas, no? Automatic gagamit na tayo na itong property na to. So, we have canceled this one. So, we have secant x is equal to e raised to ln ng cosecant y times e raised to c. And alam naman natin, cancel to, then this is of course, another arbitrary constant. So, we have secant x is equal to cosecant y times c. Or if we're going to divide both sides by c, no? So, 1 over c is still c, no? Simply c na lang siya kasi arbitrary constant to. That's the property of arbitrary constant. It just absorbs the value of other constants as well, no? When they are operated. So, cancel yung c. Okay, so we have cosecant y is equal to c secant x. Okay, so this can serve an answer, or we can simplify this from secant, no, gawin nating sines, no? From secants, gawin nating sines. So, we'll have divide both sides by cosecant y and secant x. So, magiging 1 over secant x at saka 1 over secant y. So, ang kabaliktaran nila, or okay, lagyan ko ng or is, so we'll have, that is, sin y is equal to c cosine x, or c times cosine x. No? So, yan, dalawa yung sagot natin dyan, ha? Ayan, so, anyway, they just have the same answer naman actually. No? So, when we evaluate, okay? So, yeah, no, that's it. So, we have our answer. Next, no, so we have here the differential equation 2a squared minus r squared dr is equal to r cubed sine theta d theta. No? So, let's evaluate. So, I can multiply 1 over r cubed kasi 'di ba r cubed is not belong to sine theta d theta. So, hindi dapat maalis natin siya dito sa side na to. So, we'll have 2a squared minus r squared all over r cubed dr is equal to ito, makakancel na yung r cubed dito. So, we'll have just sine theta d theta. Okay? Then, ito, pwede natin split, no? Dito sa numerator. No? So, we'll have two fractions. We have 2a squared r cubed minus r squared over r cubed. No? So, ayun. So, this one, pwede na nating makancel to. Ayan. Saka to, gawin ko yung green. Ayan. Then, this whole function will be multiplied to dr is equal to sine theta d theta. Okay, then we can now get the antiderivative. So we have the antiderivative. Ito, distributed natin yung dr dito sa dalawang term. So we have the antiderivative of 2a squared over r cubed dr. Actually, this is equivalent to the integral of 2, or labas ko na yung 2a squared kasi constant naman yan. A is an arbitrary constant. So we have 2a squared times the integral of r raised to negative 3 dr. So chain rule, that's minus 1 over ano lang. Then we have minus ln of r. Kasi di ba dr over r integral is just natural logarithm. So we have negative cosine theta plus c. Okay, tapos ito naman yung r raised to negative 3. So we will have 2a squared times r raised to negative 4 over negative 4. Then we have minus ln r is equal to negative cosine theta plus c. Then, cancel natin yung 2, tas yung 4. Mag-iiwan tayo ng isang 2 dito. Okay, so that is equal to negative 1 half. R raised to negative 4, ibaba na lang natin, no, para maging positive exponent. So, we have negative 1 half multiplied to a squared over r to the 4th minus ln r is equal to negative cosine theta plus c. We can cancel out the negative coefficients, no? So, yung negative 1, no? Kasi common sila sa lahat. Actually, si c, no? Pwede natin yan i-treat na meron siyang numerical coefficient na negative 1 since arbitrary constant naman siya. No? So, cancel natin to. Actually, we can multiply both sides by negative 1. No? It's just, parang, if nagtataka kayo, no? Di ba bawal mag-multiply ng any value na not equal to 1. Pwede kasi natin i-factor out yung negative 1, di ba? Then divide natin both sides by negative 1. Kasi ito, pwede tayo mag-factor out itong term na to. Same as this one. Pag pinactor out natin, magka-cancel out yung dalawang negative 1. But it's just the same as multiplying to negative 1. For negative 1 lang yun, baka may gawin nyo sa lahat ng constants. No? Iba yon, no? So, ayan. So, we'll have 1 half times a squared over r to the 4th minus ln r is equal to cosine theta plus c. This can serve as our final answer. Kasi if you're going to try, no, to combine the two r's, yung r to the 4th tsaka yung ln r, hindi na siya magiging simple yung sagot natin. No? So, kasi we're going to raise this to e, and this is a quite large, I mean, medyo malaking ano siya, coefficient siya. So, pag naging e raised to 1 half a squared over r to the 4th, which kind of does not make sense, no? If you get what I mean. So, this can serve as our answer, no? Kailan natin ginagawa yung e raised to ln? Kapag lahat ng terms ay may ln, no? Except, of course, for the arbitrary constant, no? So, ayun, no? Ginagawa lang natin yon kapag mayroong ln lahat ng terms. Pero pag ganito na isa lang yung may ln, okay na yon, no? No need to operate this using e raised to ln. Okay, then we have here, okay, our last example. So we have 1 plus y squared dx plus 1 over x squared dy is equal to 0. So let's transpose. So we have 1y squared, 1 plus 1 y squared dx is equal to negative 1 plus x squared dy. Okay? Then let's divide both sides, no? Kasi y does not belong to x and vice versa. So we can divide. So we have 1 plus y squared, 1 plus x squared. So makakancel out yung mga terms natin. Mapupunta sila sa kanya-kanyang denominator na tama na yung arrangement. So we have dx over 1 plus x squared is equal to negative dy over 1 plus y squared. Okay, now we can get the antiderivative. Diba? Okay, so what's the antiderivative of dx over 1 plus x squared? Let's check if it will fall under du over u. No? So, yung du over u natin. No? So, papasok ba siya dyan? Let's try, no? U is equal to 1 plus x squared. Du is equal to 2x dx. So, wala tayong x sa taas. Yung 2 kasi pwede natin gawan ng paraan, di ba? Divide lang natin both sides by 2. Pero yung x kasi hindi natin pwede gawin yun. No? Kailangan kasi, kapag nag-change tayo sa du na form, dapat puro u lang yung makikita natin. Bawal tayo makakita ng x doon. So, hindi applicable. Same goes with dito sa kabila. So, kapag ka naman u is equal to 1 plus y squared, so du is equal to 2y dy. So, same case, no? Hindi pwede. So, let's analyze. You can pause this video and check what is the antiderivative of the function. Okay, no? Yes, no? So, actually, the antiderivative of this function are tangent, no? So, arctangent rather. Arctangent of x and y respectively. No? So, bakit? These integrals falls under integrals yielding to inverse trigonometric function. No? So, burahin ko na to ha para maisulat ko yung tamang integral form. So, we have the integral du over a squared plus u squared, where a squared is equal to 1 and u squared is equal to, let's say, x squared muna. No? Pag integrate natin to, this will be equal to 1 over a arctangent ng u over a plus c. And alam naman natin, yun nga, a squared is equal to 1, a is equal to 1. So, mawawala lang yung 1 over a. Or I mean, magiging 1 lang yung 1 over a natin. Then we have u squared is equal to x squared, u is equal to x. No? So, we have arctangent of x is equal to negative arctangent of y plus c. Okay? So, dito yung galing ha, so form na to. Okay, so let's isolate or let's make this arctangent of y a positive 1. So, we'll have arctangent of y is equal to, lipat natin yung x sa kabila. No? So, we have a negative arctangent of x plus c. Tapos, let's get the tangent of the functions. No? Para makancel natin yung arctangent kay y. Ganun din dito sa kabila. Okay, so we'll have y is equal to, cancel nga to, no? In this case, what do you think? Pwede ba natin i-distribute na lang si tangent? Sige nga, you can pause this video and analyze. Okay, so hindi pwede. Bakit? Ano yan? Transcendental functions yan. Okay, transcendental functions are not treated the same way as algebraic functions. So we actually have a formula for this one. We have, diba, the tangent, and we can, let's say, no, we can represent these two as two angles, no. Angle A is arctangent of, or negative arctangent of x, and angle B is C, no. So we'll have, bring ko muna tong y, no. So we can use the formula. It is in the trigonometric formulas, sum of two angles. No? So we have tangent of, let's say, A plus B. This is equivalent to tangent A plus tangent B all over 1 minus tangent A tangent B. No, so A and B are the two angles na kinukuha natin. So again, A is negative arctangent of x, B is C. No, so we'll have y, we'll have y is equal to tangent of negative arctangent of x plus tangent of c, where c is the arbitrary constant. So, over 1 minus tangent of negative arctangent of x times tangent of c, rather. No? So, okay. No, this time pwede na nating i-cancel, no? Bakit? Kasi x na lang yung naiwan dito sa loob, no? So, dito cancel yung tangent, then yung arctangent. Yung negative, hindi natin yung ika-cancel ha, kasi it will be treated as the numerical coefficient of x. Then tangent c, since c is an arbitrary constant, the transcendental function of any arbitrary constant, just like e raised to c, is also equal to c. Oh, so, eto, pati ito, c na lang yan. Okay, so we'll have y is equal to negative x plus c over 1 minus negative x times c. So we have negative times negative, that is positive. So we have y is equal to negative x or c minus x, no, para mas maayos, over 1 plus c x. This is the solution, or this is the general solution to the differential equation. Okay? So, by the way, what we solved in this problem, okay, are general solutions. If we're asked to find for the particular solution, we need to have the initial value or the boundary value. So, usually naman, katulad dun sa previous natin, no? So, if we have y is equal to something when x is equal to something, doon natin makukuha yung particular solution. Then we're just going to substitute those values to x and y respectively. So we can compute the value of c, of the arbitrary constant. Then once we compute the value of the arbitrary constant, we can substitute back the value of the arbitrary constant to the general solution to obtain the particular solution. Okay, so that's it. Next topic, we will discuss the homogeneous coefficients of first order differential equations. Okay, so stay safe and God bless.